Okay. Okay, again problem. Give me a second. Charger need to come. Okay. Okay. Everything okay? Uh, okay. 2 weeks before the fluid mechanism lesson we completed, before we start the tutorial, I need to mention you have very limited time now. Limited, I mean, you have only 8 weeks, 9 weeks more. Your exam will be held starting from 10th of November. Then the first subject is engineering technology, right? Now you have, I think, timetable. Yes, timetable already released. First subject is engineering technology and BST, no? AT and BST. What's the date? 12th. It is 12th, right? No? Then what is SFT? SFT 16th, like, no, 16th or 18th. 19th and 21st. Yes, good. Okay, then the exam month you can't do any work. Okay, in exam the November, they don't take November for any work before November. Within next month, September and October, you have to complete every works. Okay, in our side, I will complete all things before November. Okay. This is very simple questions. This tutorial has in Bernoulli's theorem few complex questions. I will explain this. The basic part, the first questions are very simple. You can try and send me answers. Then we can try these questions. Okay. Okay. First question. The diagram show. The diagram is not given here. Okay. No need diagram. It is actually everything is given here. It is the diagram is, it is a shower. It is a shower, water shower like this. It is spraying water, spray out water. Okay, this type simple diagram then should given. The diagram show a device designed to spray water for garden plants. It consists of rubber tube with internal diameter 1.9 centimeter. Internal diameter, not the radius, diameter. And a water shower attached to its end, like this. The water shower consists of 24 holes. It has 24 holes, small holes, with the diameter 0.13 centimeter. One hole diameter, small hole diameter 0.13 centimeter. The speed of flowing through the pipe is given. The speed of the through the pipe, it is 0.91 meters per second. 0.91 meters per second. 0.91 meters per second. Okay, if the speed of the flowing through the rubber tube V1 and the speed of water leaving, okay, you can mark this data. You can mark this data on the given diagram or your own diagram. If the speed of water flowing through the rubber tube, that means this pipe, it is V1. It is V1. V1. And the speed of water leaving through the hole of water shower, it is V2. This is V2. V1 and V2. This letter is readable, no? Board clear? No? Clear nede? Okay. Sometimes due to connection problem, it can. If there any problem, please let me know. Speed of water leaving out from the one hole, it is V2, and the cross section area of the rubber tube is A, and cross section area of one hole is simple A, respectively. Cross sectional area of rubber tube and one hole is capital A and simple A, respectively. Write an expression for V2 when the number of holes in the water tank is N. Number of holes in not water tanks, mistake. It is shower, water shower. Shower is N using above symbol. Number of holes N, capital N. Then write an expression for the V2. Okay, can you get this? Can you get this? Send your answers. I can give you type. I can give you. Okay, this is a question. Now you can try and send me answer. It's a very simple questions. This paper you can download in the website. If you go to 3-month special program course page, you can download. I think you all registered. Okay, I need expression for V2. Can you get this? Expression for the V2. What is a V2? What's a V2? The rubber tube velocity, it is V1. The V2 is leaving out the speed of the water. Leaving out the speed of the water, it is a V2. I need expression for the V2. Expression for V2. Okay, can you get? Okay, what is a? Can you send me the common equation? What is this equation we need? Make it an equation. What is the name of this? What is the name of the equation we need for this question? In the fluid mechanism lesson. Now, if you can't remember, please get your tutor. No, Mithum, wrong. Bernoulli theorem we don't need for this type question. It is not Bernoulli's theorem. Shenan? Very good. Continuity equation. This is continuity equation. What is a continuity equation? The continuity equation is A1 V1 equal A2 V2. 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 It is a continuity equation. If you don't know Bernoulli's, if you don't know fluid mechanism, you don't know these things. You have to go through the fluid mechanism and come to these questions. Otherwise, you can't understand. Okay, we already discussed and completed the fluid mechanism theory concept and doing calculations now. Okay, A1. Okay, what is a A1? You have to select. I select A1 and V1 is pipe side. Pipe side. Then A1 is the capital A. A1 is capital A. That is the cross section area of the rubber tube. Cross section area of the rubber tube. Through rubber tube, it is moving with V1, no any difference, V1 velocity, and equal to A2 is simple A. A2 is simple A. A2 is simple A. A2 is simple A. Now it is V2. V2. Is it correct? Now can you send me your own answers? Now very simple thing asking. The question asks, simple expression for the V2. Can you send me your own answers? And now I have helped you. This is a part of answer. AB1 over A. No, no, no. It is wrong. That's why I asked you. It is not the answer. Amavi, I got? Very good. Then you have to consider there is given the number of holes here. The number of holes N. Number of holes N. Then the one hole area is given. One hole area is simple A. Then you have to multiply this one hole area with N number. Then this is the total surface area of cross section area of total small holes on the shower, on the water flower. Multiply by the V2. V2 is the asking. This is a V2. Then you can isolate the V2. Isolate the V2. Isolate V2. Then V2 equal A V1 over AN. AV1 over AN. What's the answer? A over NA, okay. Why again? Again multiply with V1. Okay, okay, same. Okay, this is the relationship. This is a V2. Any doubt, please ask? They are this type expression questions always coming as the first part. Every essay questions in first parts questions, simple questions coming this type expression questions. Expression questions. You need to prove by getting some relationship between expressions. Okay, this type. Okay, then V2 equal. How you get A into N? Why? What is the reason? What's the reason? The amount of water flowing through this tube finally released from all holes. The simple A is the one hole. See, one whole surface area is a simple A. Then you have to multiply one whole surface area into number of holes. The number of holes is N. N. The number of holes N. Then multiply by N. This is the total surface area of all holes in the shower. Then this is multiplied by the V2. V2 is the leaving out velocity. Leaving out velocity. Okay, this equation, continuity equation. Do you remember what's the meaning of the continuity? Continuity. Do you remember? We discussed in the dynamic fluid part actually. What's the meaning of the continuity? Continuity. Continuity. Okay, continuity, no need equation. What's the meaning of continuity? What's the meaning? Okay, think I have whatever tube, whatever hose, like this. What's the meaning of the continuity? Think if any fluid is flowing through this tube with continuous, what's the meaning? What's the meaning? I will ask someone. Sandeep, if I told any fluid is flowing through this tube with continuity, if it is continuity flowing, what's the meaning of this? Think water is flowing through this pipe, continuity. What's the meaning? Any idea your continuity? Shena, if water or whatever fluid flowing with continuity, then what's the meaning? Mitum? Timira? Continuity flow වෙනවා කියන්නේ මොකද්ද? Very good. The amount of enter, think within 1 second, within unit time, the amount of entering volume, within 1 second, within same time, the amount of volume of leaving out volume equal. If it is equal, that we called as continuity flow. Continuity flow. in physics, continuity is not in English වල තියෙන continuity එක නෙවෙයි. එක දිගටම යනවා කියන එක නෙවෙයි. The continuity mean in physics, this is a meaning. The amount of volume enter within unit time, it is equal to the amount of volume leaving out from the tube. That's the meaning of continuity fluid moving through this pipe. Okay, then as example, think within 1 second 1 liter of water enter to this pipe. Within 1 second 1 liter is leaving out. That's the meaning. Within 1 second 1 liter enter to this pipe, and at the same time 1 liter is leaving out. 1 liter is leaving out. Okay, now in practically, you already know, if it is cross section area is decreasing, the cross section area decreasing, what happened to the speed of the flow? Speed of the flow. If it is continuous flow, if it is continuous, what happened to the speed water flowing when it decrease the cross section area? When decrease the cross section area, now you can understand, decrease the cross section area decreasing, therefore its velocity is increasing. Now very good. If it is the cross section area increasing, its its velocity is decreasing. The v is not the volume, velocity. Now according to this thing, if I consider this end is A and this end is B, between these two sides we can get relationship A1 V1 equal A2 V2, that we called as a continuity equation. A1 V1 equal A2 V2 is the continuity equation. Okay. Go to the question number 2. First part is completed. This is the answer. Okay, again, if you not downloaded the paper, go to the website and go to 3 months program and download the paper, this paper. Okay, second part. Based on the above data, what is the speed at which water is pumped out from the hole in the water flow? Okay, what is the speed is asking. Then V2 equal, I will take this equation into whiteboard, no, green board. AV1 over simple A. Now we have equation according to this continuity equation. We have equation V2 equal AV1 over AN. Okay, now what is the cross section area of the large pipe? Cross section area of the large pipe, the diameter is given in the above question. The diameter of the pipe is 1.9 centimeter. The diameter of the diameter is given 1.9 centimeter. Diameter mean what is the radius? The radius is 1902. It is 10.5. That means 1. Sorry. What's the radius? 0.85. 0.95. Okay, the radius is 0.95. Therefore, 5r square. This is the cross section is circular. Then 5r squared. 5 r, instead of r squared, I can substitute 0.95 square centimeter. Don't need unit now because both given in centimeters. Therefore, we can substitute and cancel out units. The V1 is given. The flowing speed of the tube is given. Flowing speed is 0.91 meters per second. 0.91 meters per second. 0.91 meters per second. Meters per second. It is, if you want unit, you can unit here. It is square centimeter because it is surface cross section area. It is 0.91 meters per second, ms minus 1 meters per second. 0.91. And one hole diameter of one hole is 0.13. Then what is the radius of one hole? One small hole radius? 0.13 is the diameter. .065, right? Great. 0.065. 0. Then 0, then again 5 r squared 0.065 squared cm squared into the number of holes 23, right? 24. Okay, this is a expression. You can 5 to 5 cancel out. Okay, these cancel out parts again don't need to multiply and don't need, you can cancel out. 5 centimeter squared cancel out. 0.9 square you can multiply with 0.91 and divide with 0.065 square into 24. Okay, just calculate a calculation. Okay, using calculator you can within few seconds you can get the answer. Okay, get the answer with calculation and send me. Okay, what's the answer? Yes. It is 7.26 meters per second. 7.26 meters per second, ms minus 1. Now you can understand the V1, the pipe flowing is inside the pipe, water flowing speed is 0.91, less than 1 meters per second speed. But by this shower, small holes, we can speed up to 7 point more than 7 meters per second speed by using this continuity flowing. Continuity flowing, that's the meaning of the continuity flowing. Understood? If any doubt, please ask. I think these things we already discussed. They are very simple things. Okay, now if you practice few questions only, you can do any question. Actually, today our target is discuss Bernoulli's theorem questions. Okay, in this paper, I think if you go through the paper, you can find a lot of good Bernoulli's theorem questions, every type Bernoulli's theorem questions. As we discussed in the examples of Bernoulli's theorem, it is given good questions in exam from basic type to most advanced type questions in the tutorial I have included in the tutorial. Okay, any doubt? Okay, go to the next one. Okay, third part of same question. If one end of rubber tube is ground level and the other end with the water shower is placed at the height of 5 meter above ground level. That means this is the one end of pipe and the shower is 5 meter above, like this. The height is, think this is the shower, the height from the ground level is 5 meter. 5 meter above ground level, and water is sprayed from and the pressure at the from it, and the pressure at the end of ground level is this point. This point pressure is given. This point pressure is given. What is the pressure near the hole in the water spout? Density of water given. Okay, now what is the concept you need to use? The pressure also coming for that. What's the concept? What is the principle we need? Okay, we ask this. Because done on principle. Pascal. Pascal is understand these applications. Pascal is Pascal එකේදී වෙන්නේ pressure transmission. Pressure transmission always. By applying small force, by pressure transmission, we obtain large force. හරිද? පොඩි force එකක් දීලා ලොකු force එකක් ගන්න එක තමයි මේක. Pascal එකේදී වෙන්නේ. දැන් මේක force එකක් ගන්නවද? Is there any force outcome? No any force. Only high speed water flow. Increase the velocity of the water flowing. Okay, that's only. Then what is the concept? What is the principle? Very good, Mithu. Amai, what's the principle we have to use? Yes. Now Bernoulli's theorem. Okay, now can anyone explain what's the meaning of the Bernoulli's theorem? They are very simple Bernoulli's theorem. Okay, actually they are not. They are basic in like O-level question in Bernoulli's theorem. A-level, O-level type question, not A-level type question. Very simple questions. Very simple. Wait. Okay. Actually, they are very basic level Bernoulli's theorem question. Okay. Okay. Before we go to the apply Bernoulli's theorem, can anyone explain what's the meaning of the Bernoulli's theorem? Okay. Simply, actually, Bernoulli's theorem and this physics concept very easy if you understood very well from the beginning of the lesson. If you understood very well, they are very simple questions. Very simple concept. Okay, what is the name of that? This name is very important. That we call set of collection of streamline. What's the name? Collection of streamlines. What's the name? Stream tube. Good. Stream tube. Yes. Collection of no lamina flow, Arshad. Lamina or steam flow, correct. It is a this one line we called as this one line is the path of lamina flow, path of lamina flow molecule. एक molecule එකක් ගත්තහම මේකේ path එක තමයි that's a streamline. Not the stream. Okay, they are streamlines. These lines are streamline. The collection of streamline that we call as stream tube. You can go to again your tube. Okay, everything I have given. This is stream tube. Okay. What is the Bernoulli's theorem? Bernoulli's theorem means any fluid is moving with laminar flow in continuous way. Laminar flow in continuous way. There is additional characteristics. Incompressible non-viscous flow. Incompressible non-viscous fluid. I'm not going to explain again what's the meaning of incompressible and what's the meaning of non-viscous. You can go through the lesson. The incompressible mean with pressure volume is not changing. Non-viscous mean with respect these layers, between these layers in laminar flow, it is moving with layer by layer. Between layers, no any frictions between these relative layers. Okay. Now, if we consider incompressible non-viscous laminar flow when moving as a continuous flow, this characteristic compulsory. මොනවද ඕනේ? මේවා compulsory, incompressible, non-viscous, no any friction, non-viscous, fluid. They are fluid characteristic flowing as laminar flow. Laminar flow or stream flow. Laminar flow as continuous flow. Okay, with all characteristic, if any fluid flow in continuously, this one steam tube, one steam line, if you consider one steam line, make a steam line, one steam line, it's this, if we consider this green blue color one, its total energy is a constant value. That's the Bernoulli's theorem. It's this type flow occur in this type flow in the same streamline, the total energy is the constant. What is the meaning of total energy? What's the meaning of total energy? The total energy means pressure plus kinetic energy plus potential energy. Pressure plus kinetic energy plus potential energy. Then we can say the pressure plus kinetic energy half mv squared plus mgh equal constant. That is the Bernoulli's theorem, but it is not the actual Bernoulli's theorem. It is basic, but in actually it is total volume. Sorry, the total energy at unit volume is constant. Total energy at unit volume constant. Okay, then if it is unit volume, it is modified as half rho v squared plus rho gh equal k constant. Okay, this is the simplest Bernoulli's theorem. Every point on the same streamline, it is a constant mean. Every point on the same streamline, this value is a constant value. May value a constant value. Every point on the same streamline, that is the Bernoulli's theorem. That's the Bernoulli's theorem. Okay. According to Bernoulli's theorem. Okay, now if any sometimes exam in the first part of the essay questions always asking write down the Bernoulli's theorem. Then how we explain? Okay, you want to start from here. Incompressible non-viscous fluid flow as a laminar flow as continuously. Same streamline. The total energy at unit volume is a constant. The total energy at unit volume is constant. The total energy at unit volume is constant. The total energy at unit volume is constant. Understood? Can you write down some definition for the Bernoulli's theorem? Don't need to by heart these terms and definitions. You should have some idea. Okay, this type fluid when flowing as a continuous flow, on the same streamline, the total energy at unit volume is a constant. The total energy at unit volume means pressure plus kinetic energy at unit volume plus potential energy plus unit volume. This is the equation. Clear? Ashat? Okay, now we move into questions. Now we don't have time to theory discussions. Okay, this is our Bernoulli's theorem. This is our Bernoulli's theorem. Okay, go to the question. Now, if you draw a sketch diagram, it is very simple. One end of rubber tube is ground level. Okay, I'm going to draw a sketch diagram. You can draw in your paper sketch diagram. Okay, I think this is my ground level. This is ground level. And this is the water pipe. I'm drawing with blue color. And it is going up. And this is the shower. This is the shower. They are holes, small holes. Now you already know on this point, the end of the ground level, the pressure is given. The pressure value is given 2 into 10 to the power 5. It is not the 105. 10 to the power 5 Nm minus 2. 2 into 10 to the power 5 Nm minus 2. Now you already know this inside the pipe, the water volume is given in the, sorry, water speed is given in the previous part. It is 0.91. Okay, every data you can mark on the 0.91 velocity equal 0.91 ms minus 1 meters per second. This is the pressure. This is the pressure. This is the pressure. Okay, now leaving out volume, leaving out velocities v2, it is v1 that we found in previous part. What is the previous part answer? Previous part answer 7.26 7.26 meters per second, ms minus 1. Okay, now still it is moving, it is flowing as a continuous flow, therefore the speeds are same. Speed speeds are same. There is no way to change these values. Okay, that's and this pressure is asking, question asks this pressure. This pressure is asking, in near to this pressure is asking, and this height is given in the question. This height is given, it is 5 meter. 5 meter. Okay, that's all. Every data I have marked on my sketch diagram. Okay, now in the calculation, I think for easy calculation, the ground level as A. Ground level, this point I think as A. This whole point I consider as B. Okay, for easy calculate. For easy calculation. Okay, now you can use Bernoulli's theorem. According to Bernoulli's theorem, according to Bernoulli's theorem, according to Bernoulli's theorem, according to Bernoulli's theorem, A point total, A point, not compulsory write down this term, write down this like this, but for your better understand, you can write down A point total energy at A point, A point total energy at unit volume equal to B point. It is a constant. No? If it is constant, A point total energy at unit volume must equal to the B point total energy at unit volume. B point total energy at unit volume. Okay, that's the concept according to Bernoulli's theorem. According to Bernoulli's theorem. Okay, after that, I'm going to substitute values. I think P A side pressure is PA, I think. Okay, I think plus half rho V1 square. I think the ground level A side velocity is V1. A side velocity is V1 and H rho G H rho G H1. Okay, actually in A side no any potential energy, but I added potential energy as well. It is actually 0. No need to calculate because you already know it is ground level. In ground level, no any potential energy. Potential is 0. It is no any comparison height. Therefore, it is 0. But I added to the equation equal to B side. B side. I think pressure on these small holes, it is PB plus PB plus half rho B 2 squared plus rho GH 2. Rho GH 2. And actually, this the opposite side. B side has a potential energy. Ground level don't have potential energy. This side potential energy compulsory. Okay, now I am going to apply substitute values. Okay, PA value given. PA value 2 into 10 to the power 5 Nm minus 2. Nm minus 2 plus brackets plus half rho. What is the rho value? The question given, take water density as 1000. Then I am substitute 1000. V1 squared. Squared means 0.91 squared. 0.91 squared. 0.91 squared. Equal. Why I am equaling here? Because I'm not going to substitute rho GH because H equals 0. I already know. If you want, you can write down. H is 0. The H 0 means all rho GH is 0. Okay, therefore I not take space for this one. Okay, this they are clear. Are they clear? Clear. Okay, then PB is asking the question PB plus rho is 1000. V2 square is 7.26 squared. 7.26 squared. 7.26 squared. Plus, I'm going to write here. Rho is 1000. G is 10. Gravitational acceleration. H2 is 5. H2 is 5. Okay, this is a substitution. Now you can get the values. 2 into 10 to the power 5. That means 2 lakhs. 2 lakhs. Okay, can you calculate this? PB is only PB you don't know. PB with Raganthi. I think you can know. Anyone, please, if you have doubt up to now, please ask. They are very simple Bernoulli's theorem applications. Two into 10 to the power 5 plus half into 1500, 500 into 0.91 square. Okay, that's you need to calculate by calculator. 500 by 0.91 square. Okay, get value and send me, please. Okay, quickly. Now this type calculations you can do. Now you are PB plus 500 into 7.26 square. 26,353.8 plus 5,000 into 10, it is 10,000. 10,000 into 5, 10,000 into 5, it is 50,000. 50,000. Now you just only need to isolate the PB. PB equal. Now, not fluid mechanism, they are substitute isolation. PB equal 50,000 plus 26,000, then 76,353.8 divide by, not divide, subtract. Subtract, no? Yes, subtract this value. Plus 414.05 0.5 minus 76,353.8. Yes, answer is 124,060, no? 0.7. PB equal, they are the calculation actual. 124,000 60.7. What is the unit? What's the unit of this large calculation? Long calculation, finally, if you not added unit, that's no marks. What's the unit? What is the PB mean? Okay, please answer. Pressure, it is pressure. Then the answer is Nm minus 2 or Pascal. Okay, Nm minus 2 or Pascal. Nm minus 2 or Pascal, both correct. Or Pascal. Pascal. Okay, actually after this point, after this part, no any fluid mechanism. After the third step, no any fluid mechanism. It is only calculation. No, the calculation part only no difficult. It is only addition and subtraction, no multiplication steps. Okay, these two steps are the Bernoulli's theorem. Okay, please, any doubt, please ask. They are the Bernoulli's theorem, simple calculations. Okay, actually, in Bernoulli's theorem, principle no any difficult, only calculation part little bit difficult. But that is a basic calculations of Bernoulli's theorem. Okay, if any doubt, please ask. Any doubt, please ask. No doubt. Okay, understand the basic. I mark all data on a sketch diagram. Then I consider this ground point is A and the shower hole is B. Okay, then this A point total energy at unit volume I equal to B point total energy at unit volume. Then the same equation I substitute both A and B point values. Then I isolate the PB. The PB is the B point pressure. B is the small hole. Clear? Please send me quickly. Shenan, Adisha, Ashat. Great. Okay, first part is completed. First question. Then after that, very simple questions you have. Actually, this questions for you. The mass of the metal cube with a side length 2 centimeter was 79 gram. Find the mean density of the metal cube. Mean density mean average density. Average density of the metal cube. Question asks mean density. Mean density mean average density. Average density. Okay. I can give you 2 minutes. Quickly get this. Only unit conversion you have. Simple question. The mass of the metal cube with the side length 2 centimeter was 79 gram. Find the mean density of the metal cube. Okay, what is the density? The density is D equal mass over volume. The density is a mass within a unit volume. Then first of all, you can't find the volume. First of all, the mass is given. The mass is given. It is the mass is 79 grams. 79 gram you can convert into kilograms. 79 over 1000. This is the mass in kilogram. The volume, now only they have given one side length. Then how we get the volume? 2 cube. 2 cube. It is cubic centimeter. 2 into 2 into 2. 2 into 2 into 2. 8. 8 cubic centimeter. Cubic centimeter converted into cubic meter. I have to divide 100 3 times. 3 times. I have to divide 100 by 3 times. Okay, then this is the answer. If you now 79 over 1000 multiply by the 8. 30 to 30 cancel out. 79,000 over 8. What's the 79,000 over 8? kgm cube. Amave, I think you have mistake. Okay. So, however, it cannot be 197. 190 water density also 1000. It is a metal cube. Metal cube එක ඊට වඩා කොහොමත් වැඩි වෙයි. The answer is 9875. Others I got, they are very simple questions. Am I where you did the mistake? I think you have divided only 200s. Then that's also correct. You should need to get same answer. Then it is 0.02. Yes, it is same. 79 over 1000 means 0.079 over 0.000008. Yes, same answer come. Mohammed, I got. It is only substitute to the density equation on density equation with standard unit. 79 grams, I converted into kilogram by dividing 1000. It is one side length is 2 centimeter. Then the volume is 2 into 2 into 2. It is 8. 8 squares is cubic centimeter. Now to convert into cubic meter is standard unit. This cubic meter is standard unit minus cubic meter is standard unit. To convert into cubic meter, I divided by 100 3 times. 3 times. Okay, then 100 into 100 into 100. Mohammed, I got. Then calculate by calculate. Good. Okay, what is the mass of a solid cylinder with a radius of 7 centimeter and a height of 10 centimeter made of a metal with a relative density 4.8? The relative density is given. What is the mass of a solid cylinder with a radius? What's the mass of the solid cylinder with radius 7 centimeter and the height is 10 centimeter, made of a metal with relative density 4.8? Relative density 4.8 mean what is the density of this? What's the equation of relative density? Relative density. The relative density equal matter density over water density. Water density. The relative density is given 4.8. And the matter density we don't know, think it is x. The water density you already know 1000 kgm minus 3. Okay, then if you substitute the x is the matter density. The matter density is 4800 kgm minus 3. 4800 kgm minus 3. That's the matter density. Okay, then the cylinder density you found. Cylinder density is 4800. If you found cylinder density, now you can the question asks the mass of the solid cylinder, then the density equal, you already know the density equal mass over volume. Then the densities you found, it is 4800 kgm minus 3 in standard unit equal mass you finding. The volume is, to find the volume you have the question given radius and the height, then pi r squared h. Pi r squared instead of phi I using 22/7 for easy calculation. R squared 7 into 7, h is 10. Let 7 to 7 cancel out. 22 into 7, 154. 154 into 10, 4,800 kg minus 3 equal m over 154 0 multiplied by 10. But this value is, what is the unit? Square centimeter, not cubic centimeter. Cubic centimeter. Now again, this value you have to convert into cubic meter for get the answer, because the standard unit is cubic meter. Volume is standard unit is cubic meter. You have to convert that into cubic meter. Okay, I'm going to convert 4,800 kg m minus 3 equal m over 15,000, sorry, 1,540 divided by 100 into 100 into 100, 3 times. Divide by 3 times 100. Okay, then the answer is coming. M, you can isolate the M by cross multiplication. 4,800 multiplied by the, now it is cubic meter. Okay, now it is cubic meter in standard unit. 1,540 over 1,000,000. 2020 cancel out. 2020 cancel out. Cancel out and 0 cancel out. Then 48 into 154 over 1,000. What's the answer? Adisha, what's the answer? Seven point 7.392, correct. The mass equal 7.392 kilogram. 7.392 kilogram. Okay, this type simple calculation coming in, possible to come in MCQ paper. Okay, this type only unit conversion. Okay, you can see only unit conversion, no any advanced calculation here, only unit conversion. Okay, note down if you want. If you have any doubt in fluid mechanism up to now, you can ask. Actually, very basic questions we discussed up to now. Only unit conversion, relative density. Only one Bernoulli basic question we discussed. Okay, can I erase and go to the next question? Okay, after Bernoulli's theorem questions, we need to go for few exam questions as well. They are exam questions. Okay, they are. This is Archimedes theorem, and they are exam question, Archimedes theorem. And actually, this is the practical, actual. We discussing in the practical class, this is practical. I told practical questions always coming in structured essay. This is a theory part in the structure. Okay, we'll discuss. Okay, the diameter of position A and B shown in the figure are 7 centimeter and 21 centimeter respectively. 7 centimeter and 21 centimeter respectively. That means this diameter is this diameter 7 centimeter. 7 centimeter mean radius. If you got it is 3.5 centimeter radius, and it is the diameter is 21. That means 10.5 centimeter radius. Okay. How much force can be exerted by piston B when a force of 20 Newton applied on the piston A? We applied 20 Newton on the piston A. We apply 20 Newton on the piston A. 20 Newton. 20 Newton on the piston A. 20 Newton on the piston A. Okay, how much of force exerted on the piston B? Okay, what is the now principle? What is this principle? Force, sorry, pressure transmission. Pressure transmission. What is the principle? Guys, what is the principle? What is the principle about pressure transmission? Good, Pascal's theorem. Pascal's theorem. Okay, now you already know what is the Pascal's theorem. Before that, how we if exam question asks define the Pascal's theorem. Always, if any essay question asked from fluid mechanism or whatever physics question, few definitions always asked in initial parts of the questions. Initial part, they ask what's the Bernoulli's theorem, what's the Pascal's theorem, what's the Archimedes theorem, what's the Archimedes principle. Like few theory questions asking, and if any question asked from force lesson, they ask what express the Newton's second law, like this, define the Newton's second law, like small questions giving and enter the question and go to calculation questions. Okay, that's the nature of exam. If you go through past paper questions, you can understand the nature and the order of question asked in the exam. Okay. Okay, the Pascal's theorem is very simple. Okay, in any incompressible fluid, incompressible, I think you already know now. Incompressible fluid filled in a fully filled in a closed container. Make a incompressible. Incompressible in fluid mechanism, we consider incompressible and compressible two types of fluid. Always incompressible are liquid, compressible fluids are gases. Okay, for gases, this Pascal's theorem is not true for gases because they are compressible. Okay, incompressible, whatever liquid fully filled with closed container. Make a full කරලා තියෙනවා. හරිද? fully filled with closed container. The pressure exerted due to applied of external force, think the pressure A. Whatever pressure applied on any point, it is uniformly distributed throughout the fluid and throughout the container. That is the Pascal's theorem. If we consider if any force applied on this point applied pressure, exerted pressure, uniformly distribute every parts of the fluid and every parts of the container. That is the fluid Pascal's theorem, simple Pascal's theorem. Okay, if we consider as a applications of this Pascal theorem, we discuss the all main purpose is we can pressure transmission system like this pressure transmission system. By applying 20 Newton, we can get more force exerted and more work we can do by applying small forces. Okay, that's it. That's the applications of this Pascal's theorem. Okay, now according to Pascal's theorem, we got a simple equation. Do you remember? What is the simple equation? What simple equation? Okay, you don't need to remember. Okay, if you think this side, this type given diagram, think this is a one piston. This is a one piston, and this is another piston, small piston. Think it is fully filled with whatever incompressible fluid like oil. Whatever incompressible fluid like oil. Now think this side diameter is given, it is diameter given 21, that means the radius is 10.5 centimeter. This side diameter is 7, it's mean the radius is 3.5 centimeter. Okay, now if applied 20 Newton on this 20 Newton, actually don't need the equation, but for your easy usage, I have given equation here, Pascal's theorem. Actually, you don't need equation. According to Pascal's theorem, this point exerted force, that means PA equal to the PB. Now PA, I consider F1 over A1, force over area, that's the pressure equation. Pressure equal the perpendicular force exerted on the unit area. The perpendicular force exerted on a unit area. What is addition? It is continuity equation. Don't mix. Mix karaganne ba, that is continuity equation. A1 V1. It is force, the pressure. කොහොමද මතක තියාගන්නේ? This point pressure F1 over A1 equal to this side pressure F2 over A2. Then F1 20. This tight 20 Newton over area. It is given centimeter, no problem, both sides centimeter, therefore it is cancel out. No? Cancel out, therefore 5r squared h. No, 5r squared, it is cross section 5r squared. 3.5 into 3.5 squared equal F2, we don't know. It is 10.5 squared. 5 into 10.5 square. Okay, now 5 to 5 cancel out. 5 to 5 cancel out. And centimeter square to centimeter square cancel out. Therefore, unit no problem. Okay, 10.5 squared into 20 over 3.5 squared. What's the value? F2 equal. I got the value. 10.5 square into 20 over 3.5 square. $180, right? Yes. 180 new. 80? Is it only 80 or 180? 180 Newton. Ashat, check again. Okay, please note down. Okay, always try to by heart this equation and concept and principles. It is not practical. You cannot everything by heart and remember. You have to understand, catch the concept and keep the concept in your mind. That's only you have only method this remember these bulk modules. With other lessons, only few lessons only you can, like industrial chemistry and like lessons you can by heart if you want. Okay, these, so like these lessons also there are small concept you can keep in mind, but this lesson there is no any method to remember only by equations. You have to keep in the concept in your mind and apply this concept into the questions. That's only method you can remember and apply to the questions, these things. Okay, how about today exam? Did you try final question, 10th one? The boiler question? Timira, what happened? Ekrina, okay. Other thing, in exam you only answer for 4 questions, no? Then 4 questions, okay, you skip into question. This may they cut. Again, you can try in your free time. You can try again these 2 questions and try to get answers. Like final question, I think it's a good question. Collection of all lessons, it heat, forces, everything in there. Yeah, you can try. Freely you can try again. You did all the questions. Only need 4 questions. I told in the morning meeting. Yeah. Yeah, that's the problem. I told, watch the meeting. I have uploaded the videos. Okay, you have 6 questions, no? You in exam paper 6 questions. 6 question mean 2 maths questions. First 2 questions from maths, and third and fourth questions from chemistry. Fifth and sixth question from physics. Then I told it is maths, it is chemistry, it is physics. I told in the morning meeting, selecting method also I explained morning. I told first of all select 1 question from maths, 1 question from chemistry, and 1 question from chemistry, and 1 question from physics. Okay, in the exam also same method. Okay, you have to select one. In the exam paper, it has separated by our paper. I forgot to separate these. Okay, first 2 questions, but in our same structure I given for you. First question, first select 1 maths question, then 1 chemistry question. Easy. On your side, easy question you need to select from chemistry part, and 1 question from physics. Okay, after that, it is 3 questions. Now you need another 1 question. Now there is another 3 questions there. Okay, think you select first and second question is remain. You select fourth, then third one is remain. Okay, another 3 questions you have. Then you have to select one of these remain questions. And do that is a 4 questions. That's the selection method. Not only this exam, after that every exams, this is a method, selection method. Okay, remember, even in exam paper this is a selecting method, remember. Otherwise in exam paper also doing same. Okay, remember, this is a way you need to select. In exam also same. You only need to answer for 4 essay questions. Exam given 6 questions, same as today paper. You need to select 1 maths question, 1 chemistry question, and 1 physics question. It is compulsory. 1 question from each and every part, it is compulsory. Then again 1 question from remain 3 questions. Okay. Okay, next question, 6th one. The cross-sectional area of the main piston of a backhoe loader is 70 square centimeter, and a maximum force of 4,000 Newton can be exerted on it, the main load. If the piston is it to be applied, so force 14,000 Newton can be exerted. What should be the cross-section area of the piston? The other piston, not the main piston. Main piston cross section area given. Then very simple. Same equation. In a pressure transmission. Pressure transmission. F1 over A1 equal F2 over A2. F1. F1 is, I think, main piston is F1. F1 is 4000 Newton. 70 square centimeter, don't need to convert because cancel out units. Equal the F2 is asking. No, F2 is given. Sorry, F2 is given. It is 14,000. 14,000. 14,000 site cross section area is asking A2. A2 is asking. Now the answer coming with square centimeter. Now 0 to 0 cancel out. This 20 to 0 cancel out. Now 140 into 4 over 7. This A2. Now A2, 4A2 equal 140 into 7 over 4. Nine 980 over 4. What's the cross section area? Yes, 245 square centimeter. 245 square centimeter. Okay, quickly complete and go to the next question. If you complete, stone question. Complete? Can I raise? Guys, complete? Okay, simple question. Okay, then after that we can go to Bernoulli's theorem question. Okay, that's the Archimedes theorem question. When a stone was suspended in the air and weighted on the balance scale, the reading was 80 grams. The reading obtained by gradually lowering into a deep container of water, lowering in water, the values is given. They are the values. They are the values. Respectively. What is the upthrust force act on this stone? Okay, what is the upthrust force act on this stone? Okay, can you calculate? Can you calculate? Okay, before that, if exam asks what is the Archimedes theorem? Now we discussed every concept, principles, theorems, everything we refresh again. Final one, before go to the Bernoulli's theorem, final one, what is the upthrust, what is the Archimedes theorem? How we define? If any object dissolved partially or fully submerged in water, whatever liquid, the upthrust force act on this object equal to the upthrust force act on this object equal to the displaced volume, the weight of the displayed fluid, the weight of the displayed fluid, W, the weight of the displaced fluid. Okay, that's the simple meaning of the Archimedes theorem. The amount of displaced fluid weight, not the volume, displaced fluid weight equal to the upthrust force when any object submerged into it partially or fully. Okay, simple thing. Okay, then according to actually don't need Archimedes theorem for this. What is the upthrust force act on this stone? In the atmosphere, it is reading it is 80 gram, and they are the in water when it is lowering, submerged. Okay, then you can see the weight inside the the mass, the reading, the scale reading inside submerging in water, gradually the value is decreasing. Gradually value is increasing mean the upthrust force is increasing. Upthrust force is increasing, and after some time it is constant, no? 58, 58, 58. After some time it is constant. Okay, that is the maximum upthrust force that can act on this object. That's why it is constant. That is the maximum upthrust force act on this object. Okay, now you already know U equal upthrust force equal the weight 2 minus weight 1. The weight 2 is 80, not 80 actually, 80 over 1000, it is kilogram multiplied by 10. Why we doing like this? To convert into weight. The 80 is the mass. 80 is the mass, convert into kilogram and multiply by 10. This is a mg, mass into gravitational acceleration. Okay, minus. Now we need to get the maximum upthrust force. It is 58. 58 over 1000 into 10. Okay, get the answer and send me. 0 to 0 cancel. 20 to 20 cancel. 0 to 0 cancel. 8 over 10, 0.8 minus 0.58. 80 minus 58. What is the answer? 22. 0.22. 0.22 Newton is the upthrust force. Understood? If in doubt, please ask. Simple questions. If any doubt, please ask. Complete? Okay, I can give you time for the next question. What is the average density of the stone? Okay, upthrust force you got. It is 0.22 Newton. Okay, I got the this previous question. Are you understood? It is simple. Any doubt, please ask. Mitum, are you good? Mohammed? Understood? Please send me if any doubt. Doubt. Yes. Good. Okay, now I got this second part. What is the average density of the stone? Can you calculate? Simple question. What is the average density of the stone? Average density of the stone. Okay, actually it is a best method to find the density and the volume of any object, because the stone like objects, they are irregular objects, they don't have shape. We can't, by measuring length and width, we cannot get the volume. Okay, this type objects, for this type objects we can get the density and volume by this method, by submerged in a water or whatever uh, density known solution. density එක දන්න solution එක ගිල්වල බලන්න පුළුවන්. Okay, do you need more time? Okay, time enough. Do you have any method to get the density of this stone? Okay, it is very simple. Now you already got the upthrust force. Upthrust force, okay. Upthrust force easy. Okay, upthrust force, okay. It is simple. What is the average density? Okay, for get the density, what is our requirement? The density equal mass over volume. The mass is given already. The mass is 80. In atmosphere, the mass is 80. Then if you found the volume, you can get the if you found the volume, you can get the Chevron violet. Chevron. Then the Chevron. Okay, okay. Okay, okay. What is the average density of the stone? The density equal mass over volume. Okay, mass is given, it is 80. Mass is simple. Now how we get the volume? The water density is given. There is hint. Then if you found the uh, the water density is given, then you can find the water density. The water density equal rho equal m over v. M over v. The rho you already know, the density of water, it is 1000 kgm minus 3. It is given 1000. And the mass also given. the amount of displaced water, the amount of displaced water amount is 22, no, 22 gram. 22 gram is the amount of displaced water. Then the volume you can find. Volume you can find over 1000. Yes. Now volume equal the displaced water volume I am finding. Okay. The displaced water volume. The displaced water volume equal V equal 22 over 1000 divided by 1000. This much of small volume is displayed. This is small volume displays amount equal to the stone volume. Okay, that's the concept. Okay, now 22 over 1000 means 0.022. 0.022 over 1000. The density equal, the mass is 80. 80 divided by 0.022 into 10 to the power minus 3 divided by 1000. Okay. What's the value? Can you get this value? It is please get these values and send me. Sorry. It is 80 gram. Then again, gram also you need to convert into kilogram. Otherwise, it's not coming standard unit. Okay, get the value. 80 over 1000. Okay, what's the value? The rho equal mv. What's the value? Okay, I think you got the method. It need to come kilogram over 0.0022 into 10 to the power minus 3. Yes. It's coming small value. Okay, what's the value? Okay, it's coming small value. Get the value and go to the Bernoulli's theorem questions. Okay, this one. Okay, if I give 2 minutes, can you do this question? Can you do this question? Okay, question number 8. Question number 8, very important questions. Yeah, 3636. Yes, correct. Correct. It is the answer. It should be the answer. 3636.36. Because it is a stone, it is a large density. Yes, correct. Okay, come to this one. Okay, this is a airplane question as we discussed in the Bernoulli's theorem. Now, the Bernoulli's theorem already we discussed. Bernoulli's theorem we already discussed. Okay, if I give you 2 minutes, can you do this question? Okay, I will explain the first question, airplane question, and I will give you second question for you. Okay, now read the question carefully. They are the very important questions. The wing area of wing mean plane එක තටු දෙක. The wing area of the passenger plane is 50 square centimeter. Think the wing area mean the both side area. Both side area. The plane flies the speed of the wind passing the upper surface of the wing 140 meters per second. 140 meters per second from the upper side of the wing. And the speed of the wing passing lower surface of the, it is 80 meters per second. What is the maximum weight of the passenger plane that can have? Okay, what is the maximum? What is the maximum? What is the maximum weight of the passenger plane? Passenger plane, if the density is given in the air. The air density is given. Okay. Now, think the plane, if you consider about plane, it's the lower surface, it's a plane, it's a smooth surface, no any disturbance. This is the other surface, front area is high thickness and it is like this. This is a shape, overall shape. Okay, then when it is moving into, then speed up and moving into front, the air particles come into this direction. Air particles come into this direction, they are going like this. like this. They are streamlines going like this. Streamlines. Streamlines moving like this. Now again, going as normal. Okay, they are the streamlines. Now, this question given, when it is moving into forward, this area, the wing area is 50 square centimeter, sorry, 50 square meter. Understand very well this question. All Bernoulli's theorem question you need to apply like this. Okay, 50 square centimeter is the wing area, and the upper side speed is 140. This side speed, this point air speed, I think this is a point air space. Upper side any point air space is 140 meters per second, ms minus 1, and lower side it is b. If it is b, its air speed is 80 meters per second, 80 ms minus 1, 80 meters per second in lower side. You know, in Bernoulli's theorem, due to the shape of this airplane, the above air speed is greater than the lower side. Therefore, in above, when you increase the air speed, I told what happened to the pressure. So when increase the speed, its pressure is decreasing. In lower side, velocity is low. Therefore, its pressure is high. High pressure to low pressure, a force is exerted, and this force is exerted, this applied due to pressure difference, force is exerted on the surface of the wing area, then it is moving up, it is lifting when increase the speed. Okay, when increase the speed, after certain time it is lifting like this, as we discussed in the question, in the lesson. Okay, understood? Mohammed, understood? Shevon? Understood? Okay, now I will zoom out this. Okay, they are the given data in the question. Okay, now the question asks, with this air speeds, going up, if it is lifting this plane, what is the maximum weight of the plane that can have? Make තියන්න පුළුවන් maximum weight එක තමයි අහන්න. Maximum weight එක. This maximum weight is dangerous actually. Always we need to maintain less than this maximum weight, but the question asks this maximum weight. Can you understand the question first before calculate? Can you understand the question? The question asks the maximum weight of the plane. Maximum weight, maximum weight. To get the maximum weight, I'm going to, now I have 2 points, lower side and upper side of the airplane. I'm going to apply Bernoulli's theorem for this A and B points. I'm going to apply Bernoulli's theorem. Okay, therefore I can write according to Bernoulli's theorem. According to Bernoulli's theorem. According to Bernoulli's theorem. According to Bernoulli's theorem. According to Bernoulli's theorem, A point total energy, at unit volume equal to B point total energy at unit volume. A total energy at unit volume equal to B point total energy at unit volume. That's the Bernoulli's theorem. Simple. Simple. This is A point, this is a B point, total energy equal to the B side total energy. Then A side total energy. A side total energy. A is upper side. A is upper one. Then A side total energy. Give me a second. Okay, sorry. Now A side total energy is, now you don't need to consider about the height difference. It is not given height difference. You can neglect this. Then potential difference between two sides you can neglect potential difference. Okay. If it is neglecting potential difference, we can substitute simple. The P A side pressure I use, it is plus A side kinetic energy half rho V1 squared equal rho V1 squared. B side PB plus half rho V2 square. Okay, that's only. The potential energy don't need. Now, no any potential difference, no any considerable height difference. No any considerable height difference, therefore potential energy we can neglectable. Okay, now understand PA. What is a PA? A point pressure. Send me quickly. Quickly send me A point pressure. This is a question. Find the A point pressure. So this one. Is it given? A point pressure එක දීලා තියෙනවා. Okay, what is A point pressure? How we find the A point pressure? Any idea? Any idea how we get the A point pressure? Okay, actually A point pressure is not given. Therefore, it is no need. A point pressure you can substitute PA. It is not given. PA half Rho. Rho mean in both sides it is flowing air. Both sides flowing air. Therefore, air density you need to get. The air density 2. It is given in the question 2. V1 squared. V1 squared. V1 squared is in upper side, A side, the flowing speed is 140. 140 squared. 140 squared. 140 squared. Okay, then B side. Come to the lower side. Come to the lower side of the airplane. In lower side, what is the pressure? Is it given? No given. No any method to find. Therefore, I use PB. PB. It is not given. PB half. Half is a constant. Half. Rho. It is same air. V squared. 80 squared. 80 squared. 80 squared. 80 squared. 80 squared. Now I have equation. Now I have equation PA equal, sorry, PA plus 2 to 2 cancel out, 2 to 2 cancel out. 140 square mean Shibon, what's the value of 140 square? 140 square. Amavi, what's 140 square? Yeah, correct. 19,600. Yes. 19,600 equal PB, don't know, plus 80 square. 80 square mean 80 square 64 and 20. Now what to do? Now tell me, now the PA mean upside, this is a point, upper side pressure. PB mean lower side pressure. Now tell me, A pressure or B pressure is the higher value. Now Bernoulli's theorem, you have to think according to the Bernoulli's theorem. A pressure or B pressure is the higher value. Tell me all quickly. Adisha, A pressure or B value is the higher value. A the B the value. According to Bernoulli's theorem. Shevon, Muhammad, Shenan, Shehan, A pressure or B pressure is higher value. Amavi, A or B is the higher value. Pressure A or pressure B? Good. Yeah, all are correct. Pressure B, because the air speed is low. Air speed low mean, according to Bernoulli's theorem, air velocity low. I have given here. The velocity low mean pressure increase. The B pressure, then B is the higher value. Then I need to get this PB and PA need to get to this side as minus value. Then I'm try to 19,600 and this 6,400 get as minus value in this side 6,400 equal PB minus PB is a higher value that you need to decide according to Bernoulli's theorem. හරිද? ඒක ඔයාලා decide කරන්න ඕනේ. Then this PA I get into this set. PA. Okay, now what is the PB minus PA mean? The PB minus PA is the pressure difference between two sides. Due to this pressure difference, the airplane is lifting. Airplane is lifting due to this pressure difference. Okay, now the PB over PA, sorry, PB minus PA, that's a pressure difference. If you want, you can get it is delta theta, delta P, that's a pressure difference. Pressure difference equal 19,600 minus 6,400. 19,000 minus 600 is 13,000. 13,200. 13,200 Pascal. That's the answer. That's a pressure difference, delta P. Pressure difference between A and B. That's mean lower side and upper side of the airplane pressure difference. Now lower side is pressure higher. The lower side pressure is greater than the upper side. Therefore, high pressure to low pressure, a force is exerted on the surface of the wing area. Okay, surface of the wing area. Therefore, now you already know the pressure equal external force over cross section area. The pressure difference, now you already know pressure difference, delta P also pressure value. Therefore, 13,200 Pascal. 13,200 Pascal. F is asking, not F is asking. Now we're going to find the external force exerted upper side on the plane. The A is 50 square meter. 50 square meter. Now the F equal 13,200 into 50. Quickly get this value. 13,200 into 50. 13,200 into 50. 66. 66 and 4 zeros. Newton. Okay, this is the force exerted from downward to upside on the surface. This is a force exert. Then this is the, if it is force exert, this is the maximum weight we can include in the plane. Make it a maximum weight taker, but always for safe flight, we need to manage this weight less than this force, less than this weight. Okay, therefore maximum weight, you can write the maximum weight, it is 660,000 Newton. Okay, if this question asks what is the maximum mass of the airplane that could have, what is the maximum weight? Sorry, maximum mass. Maximum mass is 66,000. 66,000. The weight is the 660,000. 66,000 is the mass. 66,000 means 66 tons. Ton hat higher. 66 tons. That's the maximum mass of the airplane that can include for this type of speed, from this speed. But always we need to, that's a maximum. Always we need to keep less than this value for safe flight. Are you got understood entire calculation? Any doubt, please ask. Only we substitute to Bernoulli's theorem. Please ask. Do you need to explain again one more time? Do I need to explain? Arshat, Yasmin, understood or need to explain? Yes, I will explain. Okay, now think with Bernoulli's theorem. Now everywhere in this type question, everywhere Bernoulli's theorem you need to keep in mind. Okay, this is a actual scenario when it is airplane moving front, the air flowing is steam lines are moving like this. In when it is moving front, its upper side, this side, A side, air flowing speed is greater than the lower side. Therefore, upper side pressure is lower due to higher velocity of air flowing. In lower side, pressure is high due to lower speed velocity. Due to high pressure to low pressure, force is exerted. The plane is lifting that we discussed in the lesson. Okay, the same concept. Okay, now the air speeds are given. Now I consider the upper side is A and lower side is B. A side total energy equal to the B side total energy. That's the Bernoulli's theorem. Equal. Okay, then total energy, I potential energy neglecting, then PA, the equation without potential energy. Then PA we don't know. Then this is the upper side kinetic energy, PB, lower side kinetic energy. Then I got in this step, you have to decide PA or PB is the higher value according to Bernoulli's theorem. P, if we consider air velocities, if it is air velocity low, the pressure is high. If it is higher air velocity, the pressure is low. Therefore, always the PB is the, not always, in this case, PB is the higher pressure. Okay, higher pressure. B point pressure is the higher, lower side. Therefore, I PB minus PA I isolated. Higher pressure minus lower pressure. That is the pressure difference. Higher pressure minus lower pressure is the pressure difference. This pressure difference value is 13,200 Pascal. Then this 13,200 Pascal is the pressure difference between lower side and upper side. Due to this pressure difference, the force is exerted on the wing area. Now, this pressure equal to, now you already know the simple equation. Now, pressure difference is a pressure value. Okay, it is pressure F over A. The area is given in the question, it is 50. Now isolate the F. Isolate the F. Then this is the, due to these speeds, due to this air speed, this is the force exerted on the wind area. Make a force එක. Samely, it is a maximum weight that can have, the airplane can have. But with this with this weight, it is very dangerous because if there are any disturbance, it can fall down. Therefore, always we need to maintain less than weight, less than this value. You can weight take a meter. Now, in upward direction, into upward direction, this amount of force is there. 6,600,000 force into upward direction. Maximum we can include, maximum make තියෙන්න පුළුවන් weight එක, the weight of the plane maximum, it is 66,660,000 Newton. That is maximum. For safe flight, it is 6 approximate. It should be less than this value, the weight. This is maximum. Question asks maximum. This is a maximum value. Understood? Are you good? Okay. Okay, quickly note down. I'm going to move into next question. If you have any doubt, please ask. They are the advanced calculations of Bernoulli's theorem. Complete. Okay, now I will give you 2 minutes. Same method for next question. A passenger is standing near a high-speed train turning towards the road. Turning towards the road. The passenger is standing near a high-speed train turning towards the road. Okay, draw a sketch diagram. Think this is a railway, and this is a stage, railway stage, and the passenger is there towards to the train. Okay, the train comes along the road at the speed of 180 kilometers per second. Sorry, kilometers per hour, and the passes the passenger. It is this train is not stopping this station. It is passing the high speed highway train, express train. It is passing. It is moving, passing the passenger. In the air density is given 2, and the surface area of the passenger body is 0.3 square meter. The surface area, surface area is given. Find the force exerted on the passenger's body. Find the force exerted on the passenger's body. Okay, now you have to use Bernoulli's theorem, and okay, now you can try. I can give you 3 minutes. They are very simple questions. Now you already know the method. Get a pressure difference first, then pressure difference and the surface area is given. You have to assume the other side, mean back side of the passenger, no any air flowing, because no any speed is given. Only okay, you can try consume no any air flowing in the opposite direction of the passenger. I got. Ashit, I got. The pressure difference at least. Okay, you need to calculate same as previous pressure difference tama gando. Then pressure difference equal to the F over A. Quick to get this, I can give you 1 minute more. Finish. Yes, very good. Ashit, what's the value? Yeah, large force act, huge force acting, no? Like 700, more than 700. Okay, this is the question. Okay, think this is the railway. Think this is the railway. And the person is there. Think this is the stage. The person is there. The person is there towards to the rail direction, toward to the railway direction. The train is moving with this speed, the 180 kilometers per hour is the speed. 180 kilometers per hour is the speed of the train. Okay, now If it is train speed is 180 kilometers per hour, how about the around air particles? How about the around air particle speed? Arshad, very good, correct. How about the around air particle speed? Same. Around air particle also moving with same speed with train. With train. Therefore, air particle speed also same. Now, if we now we have to consider. I told this other side, backside of the backside surface of the passenger. It is 0 ms minus 1. There is no any air flowing. There is no any air flowing. Okay. Before calculation in the lesson we discussed, force is acting towards to the train or opposite side of the train, towards to the train or away to the train, away from the train. What do you think? Towards or away? The force is exerted from this direction to away or towards to the railway. What do you think? Quickly, I need response. In the lesson we discussed these examples. Arshad, the force is exerted towards to the train or away from the train. What do you think? Amavi, towards or away? Good. Arshad? Devon? Towards to the train or away from the train? Yes, very good. If there are no any air particles moving, the backside, this side pressure is very high. Due to this high velocity of the air flowing, this side pressure is low. Now, high pressure to low pressure, force is exerted on the body of the person, body of the passenger. The area of surface area of the body of passenger, a force is exerted, high pressure to low pressure, as we discussed in the lesson. Okay, now it is actually dangerous problem. It is a dangerous. That's why if it is moving with high speed train, we can feel there is some attract to the train. There is force exerted on the train. The reason, this Bernoulli's theorem. Bernoulli's theorem. Okay, now I think the train side is A. Train side is A and other side is B. Train side A and other side B. Then according to Bernoulli's theorem, A point total energy, A point total energy must equal to B point total energy. Then don't need to consider about potential difference because the train and passenger in the same line, same height level. Therefore, potential energy don't need. I'm going to substitute with the common equation P A plus half rho V1 squared equal P2 plus half rho V2 squared PA plus half the air density is given 2 v1 squared. Okay, now there is another problem. The velocity is given with kilometers per hour. Can you substitute this? No. According to question, 1 kilometers per 180 kilometers per hour mean per 1 hour 180 kilometer. 1 hour 180 kilometer. Per 1 hour 180 kilometer mean within 1 hour 180,000 meter. No, 1 kilometer mean 1000 meter, then 180,000 meter, then 180,000 meter. Then within 1 hour, if it is 180,000 meter, then within 1 second 180,000 meter, we have to divide by 3600 because 1 hour 3600 seconds. Now to cancel out 1800 within 1 second 50 meters, 50 meters, then we can say the speed is 50 ms minus 1. 50 ms minus 1, that's conversion is compulsory. Otherwise, if you doing calculation Bernoulli's theorem, if you apply Bernoulli's theorem correctly, your answer is wrong. If you not this substitution, conversion, it is compulsory. Okay, then the v squared is 50 squared now. 50 squared equal pb, now pb plus pb plus half. The air density is 2. The v2, b side, no any airflow is 0. The air velocity is 0. Now pa, I think pa still we don't know. Plus 2 to 2 cancel out, 2 to 2 cancel out. 50 square 2500 equal pb still we don't know plus 0. Now pb is the greater value. PB, I told the PB, no any air flowing. Air flowing is very low. The B value is greater. Therefore, I am going to substitute PB minus PA. PB minus PA equal 2500 Pascal. PB minus PA equal 2500 Pascal. Now, this is a pressure difference. Therefore, pressure equal F over A. The F is finding. The A is 0.3 square meter. It is given in standard unit. Pascal is 2500. F equal 750 Newton. 750 Newton. Newton. Okay, final Bernoulli's theorem question. Again, the question asks, in which direction does it work? The external force is worked into towards to the railway or towards to the train moving direction. What harm can cause this? Yeah, it is possible to accident. No? Possible to accident. Possible to accident. Possible to accident. Possible to accident. Okay, this one very important question because that's a maximum. This type question are the maximum question, maximum advanced question coming in Bernoulli's theorem. You can see in our first question. First question we discussed today, Bernoulli's theorem, very simple. Full equation we need to substitute and get one value isolation. It is easy. But now in previous questions like airplane question and railway question, then we need to get the pressure difference and substitute for whatever uh, pressure equation and you get the force. Okay, this time there is another problem coming. The problem is it has two fluids. Now, if you read this, the air flowing is moving through this horizontal pipe, and from this vertical side, the fluid is coming upward. There are two fluid now. There are two fluid now. Therefore, the calculation method, there is small difference in this method. That is small difference. Okay, if I give you 2 minutes, can you try this? Can you try this? Okay, read the question. The figure show a device that can be used as insect repellent spray. Yes, this is a whatever spray machine. Okay, insect repellent or whatever paint spray or spray machine. This is the mechanism. Air is blown through the horizontal tube is disperse the liquid in the pot. If the density of the liquid is given 800 kilogram per cubic meter and the density of air 2, find the speed at which air must be blown through the horizontal tube to disperse the liquid, assuming that the pressure inside the vessel is equal to the atmospheric pressure. And the height is given. This height is given, it is 5 centimeter. If it is not clear, it is 5 centimeter. It is 5 centimeter. Okay, they are the thinking questions actually. The Bernoulli's theorem, you have to think with hydraulic pressure. Okay, if I give you more time, can you try this? Oh, difficult. Do I need to help? Okay, let's try. Okay, first of all, you need to understand the question. Okay, that is a spray machine. It's a spray machine. Okay, do you know? Before that, before go to the question, you need to understand how it is working. Okay, I think you already know. In the question, in the lesson, we discussed already what is the working principle of the spray machine according to Bernoulli's theorem. Okay, now think the this is a machine. The air blowing with the horizontal tube. Horizontal tube, we blowing air by using whatever air machine, we can provide air supply for the horizontal pipe. When increase the air speed, okay, air speed, after some time, on this point, understand, on this point, the velocity increase, the pressure is decreasing. But inside the pressure, inside the vessel, the question given, it is atmospheric pressure, ATM pressure, atmospheric pressure. When decreasing the pressure than atmospheric pressure, හරිද මෙතන pressure එක මේකට වඩා අඩුයි. When decrease the pressure than atmospheric pressure, what happened? High pressure to low pressure, the fluid is going up and make as a spray, release as spray, release as fluid air mixture, same as carburetor, venturi tube, everywhere same. Okay, that's a spray machine. Okay, now the question given, the density, the fluid density and air density is given and the height given. Okay, there is no any other data given. The question asks, to make a spray, what is the minimum? Yeah, what is the question? Understand first. Find the speed which air must blow. That's mean minimum speed of the air on horizontal tube required to make the spray. Spray එකක් හැදෙන්න මේක උඩට ඇවිල්ලා the flow, the fluid liquid come in through this line and make a spray. What is the minimum speed required to provide air through this horizontal line? This is a question. Okay, before that, okay, this also same as previous questions. Okay, before we go to this question, I'm going to draw a sketch diagram. Okay, same, simple. Okay, think they are the liquid, whatever insect repellent liquid. That's a liquid. Okay, I consider, and this height is given, this height is 5 centimeter. It's a small machine, 5 centimeter. This height is 5 centimeter. Okay, understand very well, focus very, very well. This is very important. Okay, now are you tired? I think no need the interval. Other questions are homework. After discussion, we can finish today. Because we discussed every type of questions, Pascal's theorem, Archimedes theorem, relative density basic things, finally Bernoulli's theorem, every type completed. Other questions are homework. You can try. I will give you answers after you complete. Tomorrow we start your final lesson, electronics. Final lesson, electronics, starting from tomorrow. Within this month, hope to cover this electronics. Okay, this one, first of all, you need to understand what happened in the spray machine according to Bernoulli's theorem. It is working according to Bernoulli's theorem, yes. When increasing the air flowing speed, the velocity increase, the pressure decreasing. Pressure decreasing. You know, inside the vessel, inside the container, no any air flowing. Air flowing is not. Therefore, it is atmospheric pressure in normal pressure. Think isolate. This is my A point. This is my B point. Inside whatever point, this is my B point. A point and B point. Okay. This is my A point. A point is this nozzle point. This is my B point. B point. A point and B point. Now I think I'm going to use Bernoulli's theorem for this spray machine. Okay, according to Bernoulli's theorem, A point, now you already know, A point total energy equal to B point total energy. A point total energy equal to B point total energy inside and nozzle. Inside and nozzle. Okay. I select any point, but inside everywhere these values are same, pressure and everything is same. Okay, now A mean nozzle. Okay, nozzle. If you consider this inside, it's the velocity is low. Velocity low, pressure is high. This due to this pressure difference, the liquid is going lifting and make as spray. The spray is make due to this pressure difference. Due to this pressure difference. Okay, now A total energy, A point total energy we can get. How we get the A point total energy? Pressure A, PA plus half rho V1 squared equal rho V1 squared PB plus half rho V2 squared. Rho V2 squared. Okay, if you go to the question, if you go to the question, PA inside the pressure, inside, yeah, potential energy. Actually, for this type question, if you got the potential energy, it will too complex. Okay, therefore, yeah, good question. There is a height, 5 centimeter height. This type very small height, actually we not going to consider very small height, like airplane, like 5 meter to 10 meter height only we consider as potential difference. Okay, good question. We neglecting, okay, we can neglect. Okay, but this height we need to consider for the final question. I will show you. Okay, the PA we don't know. PA done. Then half rho V1 squared, that is asking and this rho is given, it is 2, sorry, it is 2, and V1 square is asking the question. V1 square, the moving speed, air blowing speed. PB don't know. How about the air velocity in the inside the vessel? Inside, no any air velocity, 0. No any air velocity. Actually, don't have any air velocity inside the vessel. It is full closed system. Now 2 to 2 cancel out. This part all cancel because it is 0. Now PA plus V1 squared equal PB plus 0, don't need, plus 0. Then PA. Now tell me, PA or PB is the higher pressure? PB is the higher pressure, yes. PB is the higher pressure inside the vessel. Inside the vessel, higher pressure. Then PB minus PA, that is the pressure difference, equal V1 square. Pressure difference equal V1 square. Pressure difference equal P1 square, V1 square. Okay, then if you need to get this answer, we should have found the pressure difference. If you found the pressure difference, that is answer. If you find the pressure difference. Okay, what we can do? What we can do for this? Now, okay, actually, this much of PA minus PB minus PA pressure difference, if we can maintain with this speed, then that is enough for come this hydraulic pressure, come this liquid into nozzle and make as spray. Make a spray එකක් වෙන්න A pressure එක ඇති. This PB minus PA pressure. Okay, its value is V1 squared. Therefore, the P pressure equal, inside the pressure equal, we can equal this value into H rho G, because it is inside the tube. Inside the tube, it is, if it is lifting up to nozzle, it is hydraulic pressure. If this pressure difference, PB minus PA pressure difference equal to H rho G. H rho G means 5 centimeter, 5 over 100. Rho mean 800, it is given. And gravitational acceleration. If this pressure difference value, if we can maintain, this is the velocity. Okay, then B minus PA equal to VA. Then instead of PA minus PB minus PA, I can substitute P1 squared. V1 squared equal 2020 cancel out. It is 400 square. 400 V1 square. Then V squared, V1 equal 400 is square root. It is 20 meters per second. 20 meters per second required. 20 meters per second air flowing is required to at least it is coming into this minimum, okay, minimum required to come this fluid into this nozzle and make gas spray. Understood? Any doubt, please ask. Any doubt? Arshad, I got? Am we good? Tenan? Okay. Okay, note down quick. Devon? Okay, quickly note down. Complete. Complete. Okay, can I raise? Okay, final question for today. The Archimedes theorem question. This one. This is a small question. Small question in the exam. Okay, you have two parts for homework. Okay. Okay, you have two questions for homework. Okay, if you have time, we can discuss. Okay, this part, this question, this ship question. Okay, as shown in the figure below, as shown in the figure below, diagram ship of mass 8,000 into 10 to the power 3. That means 8,000 ton. It's a large weight, large mass. Floats in the sea and remains stable. It is stable. Okay, it is stable. And it is stable. The center of the gravity and the center of buoyancy. Okay, do you remember what's the meaning of the buoyancy? Buoyancy can you buoyancy point? Do you remember? What's the meaning of the buoyancy point? Point of buoyancy? Buoyancy point? Anyone? Mithun, what's the meaning of the buoyancy point? Yes. Others? Timira, what's the meaning of buoyancy point? What's the meaning of the buoyancy point? Devon, what's the meaning of buoyancy point? Point of buoyancy. What? Good. Arshat? Yes. Yeah, upthrust force acting point. You can see the B mean the buoyancy point. Question given B is the buoyancy point. B is given buoyancy point and G is given gravity point. G is given gravity point. Okay. What is the magnitude of each of following forces? Consider gravitational acceleration 10 Newton, 10 kg minus 2. Okay, weight of the ship. What is the weight of the ship? The mass is given. Mass is given. Then weight equal mg, no? Weight equal mg. M is 10,000 into 10 to the power 3 kilogram multiplied by 10. The answer is 10,000 into, no, 80,000 into 10 to the power 3 Newton. 80,000 into 10 to the power 3 Newton is the answer. 80,000 into 10 to the power 3 is the answer. What is the upthrust on the ship? What is the upthrust? What is the upthrust force? What? You can send. What's the upthrust? That's the exam question 2021. Any answer? Yes, the upthrust force, if it is stable and floating on the water, if it is floating on the water, upthrust force must equal to the weight. Otherwise, it is not balanced. Okay, therefore, the upthrust force U also 8,000 into, sorry, 80,000 into 10 to the power 3 Newton. 80,000 into 10 to the power 3 Newton. Okay, how must the lines of the action of weight and upthrust be positioned for the stable vertical flotation of the ship? Okay, I need your comments. How must the line of acting of weight and upthrust be positioned for the stable vertical floating of the ship? Stable vertical floating. Stable vertical. Understand the question. Okay, you can send me. We already discussed in the lesson with a small practical. Also, we discussed. I told according to this principle, the lactometer or the hydrometer is made by the according to this principle. I told with pencil example I explained in the lesson. Yeah, what do you think? Quickly. Yes, very good. They, how must the line of acting of weight upthrust be positioned for the stable vertical flotation of the ship? The thing is they should act on same line. The question asks the line, they should act on same line. They should act on same line. Not should, must. They must be act on same line. Same line. The question asks same line, and I told for stable flotation, if it is stably floated, actually this method is wrong. Do you remember I told for stable flotation, the gravitational point must have in lower than the buoyancy point. Now in gravitational point in up, therefore it is dangerous actually. If there are no, any disturbance, it is rotating. If there are any disturbing, it is rotating. Therefore, this question asks how much the lines of acting they must act on same line. That's the answer. Same line. If there are any different lines, it is rotating. Okay, now you can see the dangerous point. Under a stormy conditions, the ship comes to a tidal position from the previous stable vertical flotation as shown in the diagram below. If the horizontal distance between G and B is 50 centimeter, okay, G and B is 50 centimeter, 50 centimeter, calculate the moment of couple acting on two forces. Okay, moment of couple of force. Do you remember? Moment of couple, moment of couple, moment of couple. How that we calculate? One force multiplied by the perpendicular distance between two forces. Now one force is, we found 80,000 into 10 to the power 3. It is a Newton. It's Newton. Okay, please practice these questions again. If I do, you have to practice again. If I doing here, you have to practice again for better understand with alone, with thinking these questions. Okay, the distance is 50 centimeter. 50 centimeter means 0.5 meter. 0.5 meter. Then the value is 40,000 into 10 to the power 3 Newton meter. 40,000 into 10 to the power 3, because multiplied by 0.5, it is half. Is the direction of the above moment clockwise or anti-clockwise? What do you think? This one, the moment is clockwise or anti-clockwise? The ship is rotating to clockwise direction or anti-clockwise? Quickly. Ship rotating to clockwise or anti-clockwise? Clockwise or anti-clockwise? Devon, it is clockwise or anti-clockwise? Arshat? Yes. It is clockwise rotation. The answer should be clockwise. Clockwise. Would the ship come back to its stable vertical flotation? What do you think? Yes or no? I stable whenever. Yeah, it is a good point. Come to stable or not? Yes or no? Quickly, quickly, quickly. Now 10:30. We need to finish now. Yes or no? I ask. Is it again become to stable or not? Amai, what do you think? Again come to previous position or not? Yes. No, Arsha. It is not again come to previous position. The reason is the gravitational point upper than the buoyancy point. The gravitational point upper than the buoyancy point. If it is it rotate like this. Think this is the ship. Think this is a ship and it is rotating. It's rotating with this gravitational point and this is buoyancy point. It again stable. Again it turn into correct way and stable. But in this way again it not the gravitational point up. Therefore, due to this region, it is continuous clockwise rotation. Continuous rotation. Continuous rotation. That's the reason I told for stable with even in disturbance condition. If it is stable, I told the gravitational point need to get into lower end and the more than buoyancy point. Gravitational point එක යට නම් විතරයි. It is stable always. Keep stable. Okay, therefore it is not coming. Give reason for the answer you gave in the part 3C, previous part. Why it is not coming? You can explain the gravity point. Gravity point is upper than buoyancy point. Therefore, it's continuous rotate into clockwise direction. Okay, this type, any method, any way you can explain, the gravity point is upper than the buoyancy point. That's why it's not again come to stable position. Okay, they are the exam question and most possible advanced questions, basic questions to advanced question. You can try these two remain two questions. If you have any doubt, please you can ask me. Then I will explain. Okay, if we have time in next week, we can discuss. Now 10:40. I have special work before 11. I need to finish today. Okay, everything I got. I got everything. Okay, then don't miss next tomorrow class. Tomorrow we start your next final lesson, electricity, and last part of the cell structure. Okay, last part of cell structure also we can discuss there. P part, no? Okay. Then it's a small part. Then we can start the uh, electricity final lesson, and we have again environment chemistry only. Environment chemistry also very simple. I told read the tooth. Then we can quickly finish the lesson. There is no any calculation, only environment effect, the chemical industries and human activities, how effect to the environment. Okay, that's entire lesson explain that. How effect to the atmosphere, how effect to the lithosphere, how effect to the hydrosphere, everything explaining. That's only how human activities and technological approaches, technological activities, how effect to this different environment areas. Okay, that's only entire lesson. Okay, you can read and get some idea, then it is easy to me when explain. Okay, compulsory read. Now this time time management is very important, because you have very limited time now, only few days now. Time remain for the exam, you can count by days. Okay, therefore this is the time you need to work very uh, focusing into your targets, and always try to balance with other subjects. Now I know in SFT every week's doing lot of works, but try to balance with ET, BST, and other ICT or whatever subject. Try to every weeks, at the end of the week, you should satisfied with your works. Okay, every weeks, not only weeks, every day actually. Every day at the when completing your works, you need to satisfy your daily works. This few days only you have to work like this. Okay, if you continue within this remain 70 to 75 to 80 days, you can get you can go to your maximum result in your capacity. You can get maximum result. I know everyone cannot get A, but if you have capacity to get A, if you not work for this, it is a problem, a kapara. Therefore, if you have capacity, you have to identify if you have or not. Okay, if you have capacity, you have to work somehow. You have to work and you have to get this achievement. Okay, that's all for today. Okay, I think you now you work on past papers now. With other subjects also you doing papers. Okay, I think other subjects also exams important. because exams you can measure your working pattern. Only working, only reading and memorizing not enough. You have to face for exams, like our today exam. Okay, that is a, you can get more experience, and more than knowledge, you can get experience how to manage time, and what you need to cover more, and you can identify. It is very important this time, because if you think you can this lesson, whatever lesson, if you think you can this lesson, but actually any part not covered, to find this you have to face for exams, very very important. Okay, therefore other subjects also, I hope you working like this, not only SFT. Okay, that's all for today. Good night. Try to balance all three subjects always.